Hi, I'm Alex Kiss, and this statistics video will be on an example of the one-sample z-test. In an earlier video we had covered the ideas behind the test, and I've put the summary table here again. Let's go over a quick review of it. The concept of the one-sample z-test is that the mean of a sample is compared to a population mean where the population standard deviation is known. Keywords and key idea behind this test are we're looking at data from a normal distribution. We have a population standard deviation, which is represented by sigma. The hypothesis form, mu the mean equals c some constant, is the null hypothesis versus the alternate HA, mu not equal to c. And the test statistic is z equals x bar minus mu divided by sigma over the square root of n, where x bar is the sample mean, mu is the population mean, sigma is the population standard deviation, and n is the size of our sample. For our example, we're given that IQ is normally distributed in the population with a mean of 100 and a standard deviation of 10. A professor has told you that his class of 40 students has a mean IQ of 110. You wish to test if this differs from the population mean. Since there is only one sample, we know we're looking at a one-sample test. We're told IQ is normally distributed, so we'll consider a test that applies to normally distributed data. Having data that's normally distributed means it can be characterized or parameterized by its mean and standard deviation. Therefore, we're looking at the use of a parametric test. We have the population standard deviation, which is a value of 10, but not the sample standard deviation. Therefore, what we know is that we have one sample, data being normally distributed, and we have a population standard deviation. This is going to lead us to the choice of the one-sample z-test. Our hypothesis statement for our specific question is going to be h naught, the null hypothesis, mu the mean equals 100, versus HA, the alternate hypothesis, mu not equal to 100. Our test statistic is z equals x bar minus mu divided by sigma over the square root of n. X bar, the sample mean for our example, is 110. Mu, the population mean, is 100. Sigma, the population standard deviation, is 10. And n, the size of the sample in this case, is 40. Placing those numbers into the test statistic, we get 110 minus 100 divided by 10 all over the square root of 40. This gives a z statistic value of 6.3. A z-value of 6.3 corresponds to a p-value of p less than 0.0001, which is a highly significant finding. We therefore conclude that the class's mean IQ of 110 differs significantly from the population average IQ of 100. For further information on statistics, feel free to see any of our other videos, visit our website, or download our Statistics Professor app.